talk a little bit about geometry. Okay. Now you saw from the general topics yesterday that we needed to talk specifically about surface area and volume. Why are we not talking about area and perimeter? We've already done that, right? We've already worked on that. But if I gave you problems on area and perimeter, would you knock those out of the park? Yes. Okay. Surface area and volume. Just as a reminder, surface area is the area of all the surfaces added together. So to find the surface area, find the area of each surface and add them. Any questions about that? Now, did I give you a formula for surface area? No. Why? Do you know? There's tons of them, right? It depends on what shape you're getting a surface area of. If you're getting a surface area of a cylinder versus a surface area of a sphere versus a surface area of a triangular prism versus the surface area of a rectangular prism, there's tons of formulas for that. But if you'll just remember that the surface area is all the surfaces added together, you almost don't need a formula. You just find all the areas, add them together. Does that make sense? Okay. Volume. Volume is the amount of three-dimensional space that the object occupies. How come I didn't give you a formula for volume? There's a lot. Okay. There's a lot. I believe when I took the test, if I'm remembering correctly, I don't think I had a surface area problem, but I'm pretty sure I had a volume problem, and it gave me the formula I needed for a volume. Okay. Right triangle trigonometry. Remember yesterday we talked a little bit about what that meant? Okay. There's 3 sections today that we're going to talk about right triangle trigonometry, but you need to remember SOHCAHTOA. Okay. When I took it, I didn't have any SOHCAHTOA problems. Okay. Miss Patton and Miss Matos, they both had 1 each. Okay. They remember that because they're geometry teachers, so they remember having a problem like that, right? I remember not having a problem because I'm not a geometry teacher, and I was glad I didn't have to do one. Is that fair? Okay. So I put that on there just as a reminder. You need to know because these formulas are not going to be given to you. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You good? Okay. Special right triangles. 45, 45, 90, and 30, 60, 90. Okay? 45, 45, 90 says that this leg and this leg are x. Then the hypotenuse is x root 2. So if I tell you that this leg is 5, what is the hypotenuse? If this is 5, if x is 5, what is the hypotenuse? 5 root 2. If I tell you the hypotenuse is 7 root 2, what's the leg? 7. Does that make sense to everyone? Okay. Then there's the 30, 60, 90 triangle. Okay. If you just have to be careful, right? I remember the 30, 60, 90 triangle by 1, 2, square root of 3. Because to me, the numbers go 1, 2, 3, right? Now, I also have to remember that 2x, this is the hypotenuse. The one with the 3 in it is not the longest one because it's the root of 3. Does that make sense? Okay, so I have x, 2x, and x root 3. You have to remember that x is opposite of the 30 and x root 3 is opposite of the 60. All right, so let's try this a little bit. If I tell you that the angle or that the length of the side opposite of the 30-degree angle is 2, how long is the hypotenuse? 4, because it's 2 times 2. And how long is this other leg? 2 root 3. Okay? If I tell you that this length right here is 6, how long is this? 3. And how long is this? 3 root 3. Does that make sense? Anybody have questions about special rights? I know 100% that this is not the first time you've seen it, but it's been a while, right? So I'm just helping to remind you, yes? Okay. This is the only part that we actually have problems that I want to do with you together on this page. All the rest of them are somewhere else, and I'll tell you where those are in a minute, okay? But before we get to those, let me just tell you here at the bottom, converting units of measure. If I'm not mistaken, the one question that I had on converting units of measure, they gave me the unit of measure I needed. For example, it said 1 gallon equals 4 quarts. Like it gave me the problem that I had to do, and then in parentheses it said 1 gallon equals 4 quarts. Or it said 1 mile equals 1,760 yards or something like that. Does that make sense? It gave it to, it's not something, like I don't need to have this memorized. Does that help? Okay, so now let's go back and look at Pythagorean triples. When I said Pythagorean triples yesterday, some of you looked at me like I had 3 heads. Okay, have you ever heard of Pythagorean triples before? If you have not heard of Pythagorean triples before, I need you to ask you this. Do you know how to do the Pythagorean theorem? Yes? Then you don't really need the Pythagorean triples, but Pythagorean triples is like a shortcut. It's not magic. It's not, we're just throwing numbers at the wall and seeing which ones stick or something like that. It's like a shortcut of Pythagorean theorem. That's all it is. Because if I said, I'm telling you right now, a Pythagorean triple is 3, 4, 5. I'm telling you that right now. Okay? Well, if it's 3, 4, 5, we could prove that with the Pythagorean theorem, right? 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5. Okay? So knowing 3, 4, 5 is just a shortcut so that I don't have to do Pythagorean theorem. Does that make sense? Because Pythagorean theorem 100% still works. It's still a thing. Okay? But Pythagorean triples are, if I know that this leg is 3 and the hypotenuse is 5, I don't have to do the Pythagorean theorem. If I know the Pythagorean triple 3, 4, 5, I know this side is 4. If I know the two legs are 3 and 4, and I know there's a Pythagorean triple of 3, 4, and 5, I know the length of hypotenuse is 5 without having to use the Pythagorean theorem. Does that make sense? Pythagorean triples are not magic. They're just a shortcut for Pythagorean theorem. Does that make sense? Okay. The other one is 5, 12, and 13. Now, are these the only two? Absolutely not. But these are the ones that are, I guess, most popular. Okay. Now, I could make you a huge list of a whole bunch of Pythagorean triples. A huge list. Because here's what I know. If this leg is 6 and this leg is 8, what do you think this leg would be? 10, without even having to do Pythagorean theorem, because all of the multiples of 3 and 4 and 5 are also Pythagorean triples. Does that make sense? 6 squared is 36, 8 squared is 64, 6 squared and 64, 36 and 64 is 100, square root of 100 is 10. You see what I'm saying? What if this was 9? This would be 12 and this would be 15. So do you see what I'm saying? We can make a huge list of Pythagorean triples, but if you think about the fact that 3, 4, 5 is 1, and so are all of its multiples, you kind of got it made. Does that make sense? Same thing with 5, 12, and 13. Okay? 5, 12, and 13 is also Pythagorean triple, just like I just told you all about the 3, 4, 5. Right? So this is the one that showed up on our benchmark the other day. It wasn't 5, 12, and 13, though. What it said was 10 and 24, and it wanted to know something about this side. Well, what do you know that side is now? 26, right? Because that's doubled and that's doubled, so that would just need to be doubled. Does that make sense? Do you see how that could make things faster for you if you knew the Pythagorean triples? Yeah? So do a couple problems with me. If this leg is 3 and this is 4, what's this one? 5. Could we have done the Pythagorean theorem to figure that out? Yes. If this leg is 12 and this hypotenuse is 13, what's this leg? 5. If this leg is something and this leg is 9 and this leg is 15, what's this leg? 12. Because 3, 4, and 5 all multiplied by 3, right? Okay. What about this one? Oh, we kind of already did that one over here, right? 26. Because that's a 5, 12, 13 problem. All multiplied by 2, right? What about this one right here? A 6, a something, and a 10? 8, because why? It's a 3, 4, 5, all multiplied by 2. Okay? And what about this last one right here? First of all, do you think it's a 3, 4, 5? No. So maybe it's a 5, 12, 13? Well, if this was a 5, how would I get to 25? Multiplied by 5 is 13 multiplied by 5, 65. Yeah, then all I need to do is multiply 12 by 5 to get the length of this leg. Does that make sense? Okay, so do you see how Pythagorean triples could make things quicker? But could you also see how you could still do Pythagorean theorem if you didn't remember these? Yes? Okay, so your homework tonight is on IXL. Okay, your recommendations are on IXL, so please make sure to get those done.